Hello students, how are you? I hope you are doing well. In this video, I have come with three questions based on modern physics. I have picked these questions from the second shift 25th January 2023 JEE mains exams. So let us discuss the first question. As you can see, the energy levels of an atom as shown in the figure. Which one of these transitions will result in the emission of a photon of wavelength this much? We'll be using a shortcut, students. The shortcut says, remember the value of h is close to the actual value. So we can straight away use the relation between the energy of a photon and its wavelength is approximately equal to this. Lambda should be in angstrom unit and this will be in electron volt. Energy will be in electron volt. I'll write it here. So kindly memorize this result and the result. It's very important. So here you can see that the required wavelength of the emission should be this much. So I'll substitute this 12400. Lambda should be converted into angstrom. So just put another multiply by 10. So I'll have this. So this much angstrom. So approximately you can see that it is around 10 electron volt. Now you can very easily see which transition would correspond to 10 electron volts. So from 0 to minus 10. So this transition, that is D, will correspond to the required what we call transition. So D is the correct answer. So I hope that is clear. Moving on to the next question. Given below are two statements. Stopping potential in a photoelectric effect does not depend on the power of light source. Yes, students, it is true because after all, the light source, the power of the light source has to do everything with the intensity, not the energy of each photon. And unless you disturb the energy of each photon in terms of frequency or wavelength, the energy coming out of the energy of the photoelectrons will not get affected. Okay, if you write the photoelectric equation, Einstein's photoelectric equation, then you can see that the energy of a photon which is completely imparted to the photoelectron, if minimum energy is spent in terms of work function, then the maximum kinetic energy will be retained by that electron. Only few electrons are fortunate enough to spend the minimum energy, which is the work function, so as to be left with maximum kinetic energy. So this maximum kinetic energy Kmax and stopping potential are interrelated to this. So that means finally I can write like this. Now these are constants. E is a constant. H is a constant. So we are left with these two, W and nu. So nu is related to the frequency of the incident light. W is related to the work function of the photometal. So statement 1 is correct. Coming to statement 2. For a given metal, maximum kinetic energy of the photoelectron depends on the wavelength. Yes, if it depends on the frequency, it will depend on the wavelength as well, because frequency is the reciprocal of wavelength. So statement 2 is also correct. So statement 1 and 2 both are correct. So correct option is the fourth option. Okay. Then moving on to the next question. A nucleus disintegrates into two smaller parts which have their velocities in the ratio 3:2. The ratio of their nuclear sizes. Here by size we mean radius. Okay. That should be clear to you. By size we mean the radius. Right. Now you see here when a nucleus disintegrates into two smaller fragments, the momentum will remain constant. Since the initial momentum is zero, the final momentum will also be zero. So that means the momentum will be equal and opposite. So that you have to be clear with this. Momentum will should be equal in value but opposite in direction. Okay. Now, sir, let us say this is coming with velocity 3v and the other is coming with velocity 2v because their velocities are given in this case. So I'll take this as first fragment, this as second fragment. So for the first it is 3v, for the second it is 2v, where v is some constant. So if I take the masses as m1 and m2, then I can write that p is equal to numerically 3v into m1. Also p is equal to 2v into m2. So from this, basically we are getting the ratio of masses as m1 by m2 as 2 is to 3. Okay. Now you know that the radius, nuclear radius, is equal to, I'll use capital R, sorry. Assuming a nucleus to be a sphere with nucleons inside it, we can write the radius, as equal to an empirical constant which is around 1.5 or 1.3 or 1.4 into 10 to the power minus 15 meter. This in fact it should be 1.3 or 1.4, anything is okay. Okay. Into cube root of mass number. Cube root of mass number. And mass number will be proportional to mass. So what I can do, if I cube both sides, I have r cube is equal to r naught cube into a. So this will be, the mass number is nothing but the mass of the nucleus divided by a mu, because mass of any nucleus is equal to the number of nucleons, which is the mass number, multiplied by a mu. So r naught and a mu being constant, I can write r cube is proportional to m. So that means this ratio m1 by m2 can be replaced by r1 cube by r2 cube. I hope you are getting my point. So if I take this radius as r1 and here the radius as r2, so I can write this as r1 by r2 whole cube. So the required ratio is r1 by r2, which is 2 by 3 cube root. You have to extract cube root on both sides. So the correct answer is x is equal to 2. Okay. So that's all in this video. Thank you so much for watching. Kindly subscribe to my channel and hit the like button. Thank you.